I hope you're having fun drawing some pictures. What else do you do in calculus except draw pictures? Right. You know, this year we haven't talked about differentiation or integration or limits or continuity or epsilon or delta. Yes, this chapter is still calculus free and will remain so until the next chapter. All right, so x is equal to 0. Okay, when x is equal to 0, of course, what you see is, and I should write this in black, y square over 4 plus z square over 16. And you have to draw this on this vertical wall. So you count 2 units to the y and negative y in the y, and negative and positive and negative y direction. 1, 2, 3, 4. No, that's this. Okay. And 1, 2. So it'll be 4, negative 4 in z and 2, negative 2 in the y direction. It'll be an ellipse. It will be an ellipse like this. Right? That's a trace. In other words, whatever this object is, I mean, this is like drawing an elephant. You know, you're touching an elephant in different parts and you're trying to figure out what the entire elephant looks like. Well, whatever this surface is, if you cut it along the plane, the vertical plane, x is equal to 0, then the cut surface or the section, you know, cross section is going to be this ellipse. All right. Let's figure out what happens when y is equal to 0. If y is equal to 0, of course, your equation will be x squared over 9 plus z squared over 16 is equal to 1. 1, 2, 3, 4, 1, 2, 3, 4. You are still picking these points. At this time, you go 3 units in the x and negative x directions. It'll be an ellipse, same height. From the top to bottom, it's, you know, height 8, right? But then this time it'll be a little wider one because this is 3 and this is negative 3. By the way, you need to do this on your own, not just watch me do it, okay? Because I mean, there's nothing like you doing this on your own paper. That's how you learn. You don't watch math. You don't learn mathematics by just watching some videos. Hands-on. Okay, so try to keep up with this by taking your own notes here. And then when z is equal to 0, your equation will be x squared over 9 plus y squared over 4 is equal to 1. And you will have another ellipse. This time you go 3 units here, 3 units here, 2, 2. Right? And then this will be, because z is equal to 0, it'll be on the xy plane. And you don't have to write all the names of these planes, but this one was xz. It's the xz plane. This is the yz plane, right? All right, let's put all of this together. What do you get, all right? So you see, you get this one first, all right? And then you see this thing here. Yeah, let's go ahead and do this. Can you imagine, just put this together mentally? Yeah, I mean, this is what you get, right? What you get at the end is basically this, right? Where is that? Well, if you want to do the xz plane cross section, you know, this is what you're seeing. And then the z, with the last one here, if you want to draw that, it sort of looks like this. Okay, so it is an elongated ball or the sphere. And we have a name for this, okay? Because you see ellipse, ellipse, and ellipse. This is a 3-dimensional version of an ellipse. And the 3-dimensional surfaces often end with an OID ending, okay? So this one is called an ellipsoid. Cool name, huh? Yes, you have just drawn your first ellipsoid in your life, probably. Okay, so an ellipsoid is a surface, it's a closed surface, there's no boundary, and it, you know, it's contained just like an ellipse. There's no asymptotes, it's not going forever. It is a compact surface and no boundary and so on. And it's called an ellipsoid, an elongated version of a sphere or the 3-dimensional version of a ellipse. Next one. So I'm going to change this just a little bit. So you had a plus and plus, okay? You had, everything was added here. That's what made this into an ellipsoid. What happens if one of them is a negative one? Oh, here, okay? Negative sign. So go ahead and try. Maybe you can pause this and figure out what this looks like. All right, ready? Set, and then again, do your 3 three traces on these coordinate planes, and you can figure out what this is, right? I'm not going to tell you because I don't want to spoil the ending, right? I mean, this is so much sort of an excitement that you should feel, right? So go ahead and try and solve this mystery. And when you think you're done, you can come back. And I encourage you to pause this right now, okay? All right, so I'm not giving you this name yet. And there's a set of parentheses because I have to enter something else here later first. When x is equal to 0, you have y squared over 16 minus z squared over 64 is equal to 1. All right, and so I hope you have an idea. Right, that's an hyperbola, 4 units to the right, 4 units, well, in the y direction. And for the z direction, you go 8, right? And so this is, and again, you don't have to draw this very carefully, but I mean, if you are to draw your your rectangles and so on, and I wouldn't bother with the asymptotes. What you can see, and again, it doesn't have to be exact here. Okay, you're not looking for foci. This is not pre-calculus. So this is what you get, right? It's an hyperbola. What happens if y is equal to 0, right? So here you get x squared over 9 minus z squared over 64 is equal to 1. So you still have 8 and negative 8. And then for the x direction, you go 3 and negative 3. And that's your guiding rectangle. And because x comes first, your hyperbola would be something like this. Okay, and really that's all you have to draw. All you have to draw is sort of a rough sketch of what these conics look like. All right, finally, when you go to z is equal to 0, this is what? X squared over 9 and plus, right? This is the first time you saw a plus sign. And of course, that's not surprising because the plus sign is between the x and y and not, and negative sign is in front of the z square term. And so this is a circle. I mean, not a circle, an ellipse. It is in the x direction, you go 3 units. In the y direction, you go 4 units. So it is this ellipse, right? Okay, can you picture this? I mean, you can even, here, let's do a little color coding. You like purple belt? Yeah, let's see. Yeah, let's do a purple belt. It sounds like, is this a purple? Yeah, this is a purple, right? Sounds like a karate or something. Okay, here's a purple belt, right? If you embed it here, it looks like this. Okay, and you can, I mean, this is no surprising. You can tell the clear picture of this, right? It's going to look like there. Okay, now here's what's happening. You have an hyperbola, another hyperbola, and one is this, and the other, if you want to draw this, it looks like this. And then the other one is an ellipse, right? And so when you have a mixture of two kinds of conics, then we name that surface based on the dominating conic. In this case, it's a hyperbola. So we will call this an hyperboloid, okay? OID, indicating it's a surface in 3-dimensional space. And one, that ellipse, okay, this will become an adjective. In English, not like in French, in English, we put the adjective in front of the noun, it modifies. So this will be called an elliptic hyperboloid. Cool name, right? Elliptic hyperboloid. And because there's only one thing like this, okay, we call this an elliptic hyperboloid of one sheet. Now, why do I have to write an elliptic hyperboloid of one sheet and specify one sheet? Okay, well, the answer is, of course, the answer is because there are other elliptic hyperboloids. So take a look at this next one, right? So what's the difference here? Well, z squared comes first. You have 2 negative signs. One side is still 1. Okay, of course, you can write this in different ways where this side is -1 if you change all the signs. But you notice here you have 1, and then you have plus, plus, and minus. This time you have minus, minus, and the plus, okay? See what happens here. And when you draw these 3 traces, you can come back and tell me what you find. I would encourage you to pause this, sketch the 3 traces so I don't spoil this for you, and you can come back. All right, so this is, we've done this a few times already. And so let's go ahead and get this done here. Z squared over 4 minus y squared over 16 is equal to 1. X is missing. So what is that? You go 2 units up here, 2 units down, 4 units in the y direction, 4 units in the negative y direction. And remember, you're drawing on this canvas when x is equal to 0. And so your graph would, well, let's see, I can draw this in black ink. What is that? It's a hyperbola, right? Yeah, it is an hyperbola. And so what do you get? Well, I get something like this. Right, so maybe I can do a little rectangle here. It's a 2 by 4, or actually 4 by 8 rectangle, right? And your graph will be in hyperbola, but this time, because z squared comes first, it's, you know, up there, right? And then for y, your canvas on which you're drawing this trace is that one. And then you do z squared over 4 minus x squared over 9 is equal to 1. So this will be 2 up, 2 down, 3 in the x direction, 3 in the negative x direction. You do your guided rectangle, which is 4 by 6. And z comes in first, so it'll be this hyperbola, okay? So far, similar to what we had before. And then something happens with z equals to 0. See, if this one is equal to 0, this is the equation you get. And guess what? I hope you didn't draw anything, because you have, no matter if x is positive or 0 or negative, I don't care, all right? This thing is going to be negative or 0. This thing will always also going to be negative. Okay, so regardless of what x and y are, if z is equal to 0, this side will never be equal to a positive 1. Did you get that? It's x, something x, I mean, x squared is always non-negative. Y squared is always non-negative. And so when you have this minus sign and then this minus sign, this side will never add up to 1. So the point is, there's nothing here. It's the empty set. There is no trace. Well, sounds interesting, right? We're talking about a mystery with no trace. Well, so you can't have anything when z is equal to 0. In other words, this is what I'm saying. If you try to draw anything on this plane, z is equal to 0, otherwise known as the xy plane or the floor, guess what? You'll entirely miss whatever this object is. We just missed it, okay? You swung at it and you missed the ball. I mean, the ball missed the bat, whatever. You know, okay, there's nothing in there. Okay, so now let's try to do for other z values, and sometimes you may have to do that. If you miss it, you try another one. Maybe if z is equal to 4 or minus 4, then what happens here? Try to plug in 4 or negative 4 here. The top is 16, right? Is that what I want? Yeah, I guess I want to do that, right? So this will be 16 over 4 minus x squared over 9 minus y squared over 16 is equal to 1. Sorry about that. All right, so I don't know if you can see this, but it's going to be x squared over 9 plus y squared over 16. Let's see. Oh. So what I'm doing is I'm moving these to the other side. And so this will be 4. I'm moving here. This will be 3, right? Yeah. So I can divide everything by 3. I mean, this will be, it's sort of unconventional, but if I divide this side by 3, I get 16 times 3, that's 48. Right? Well, this is a kind of a strange thing, but you can still tell this is going to be an ellipse, right? Yeah, it is an ellipse when x is equal to 4. So this is where x is equal to, this is the xy plane, sorry, it's messy. Yeah, this is where, here's a canvas where z is equal to 4. Okay, so the origin was like right here, and then you move it up here when z is equal to 4. It's going to be an ellipse where x, in x direction, you go square root of 3. In the y direction, you go square root of 48. It's going to be like this. Right? So did you get what this is? And by the way, this happens when z is equal to -4 as well. Okay, so what happened is if you go here, right, and then at this point there is nothing, but if you go up to when z is equal to 4, for instance, okay, then you will be seeing, let's do that black belt thing again. I mean, not the black belt, purple, all right? There's another purple down here, all right? So this will be something like this, and you can see that now you can see these ellipses, right? So what happens is, okay, I have something that looks like two bowls, two salad bowls, one moving up, one facing down, right? Never seen anything like this before. Right, you see this is a hyperbola. This is a hyperbola. And the last one is actually an ellipse for correct z values, not when z is equal to 0, but for other z values. And in fact, this starts to show up when z is equal to plus or minus 2. And for any values where the absolute value of z is bigger than 2, you'll have an ellipse, right? And so what do we call this? Ellipse, hyperbola, hyperbola. This should also be called an elliptic hyperboloid. Wow, that's the same as before, elliptic hyperboloid, hyperbola, hyperbola, ellipse, right? Except you have two components because you have two negative signs. So this is called an elliptic hyperboloid of two sheets. I like the word components better. It's an elliptic hyperboloid of two components. First one was an elliptic hyperboloid of one component. But somehow the word sheets have taken over. So there are two types of elliptic hyperboloids, one with one sheet and one with two sheets. And so I do want you to remember that. Okay, next one. I'm going to pause my second part of this, and then I'll go into my third or part 3. But I want you to do this and sketch, right? Note, this side is no longer 1, it's 0. Okay, so that's going to change things significantly because now, well, you'll see. Go ahead and do your 3 traces and come back to part 3.